Alexa, what day is it?
Today is Friday, April 20th.
Looks like our recorded date is off again. That was the audio problem. Okay, what time is it? Alexa, what time is it?
It's 8:54 a.m.
Alexa, turn on lamp 1. Now then, I've been giving you a theory and the supporting evidence, which to my thinking is far greater than the evidence of lots of theories that get accepted. It impacts a whole bunch of disciplines in a quantitative or semi-quantitative way. I don't know about you, but I find this personally is the talk I've been dreading. The computer program was a lot of hard work over a long time, and I cannot give it all to you in 15 minutes. But I can show you what, I can kind of point the building out to you, so forth. What I've written down here in red, that's what I'm saying. What you see in black and white is what I'm talking about. Links are a different color here. If you want the source code without these ramblings, go to there, or just go to nobabies.net, hunt down to where it says source code. There are 3 source code links. Click on the first one and you'll get this without quite so much stuff from me. Okay, or you can go to the same place, nobabies.net, go down to video script links, bring up the script that I'm using here that you can see, and then click on that. It'll get you the source code. All right, first thing you want to read is this documentation, and it explains what we're up to. This is before the source code itself, just saying how how we're approaching this. And then you can download the source code, which starts about there, where it says, see where it says source code there? On that document, go right behind that, and you can tell where the source code stops and starts. Okay, let me tell you something about reading source code unless you're not used to it. All right, machine code or executable code is not readable by me. It is not readable by any but a very few people. That's the experts who do nothing else. I work with, and everybody else, unless they're just a hobbyist, works with source code, which is converted by a compiler, which is a program, into the executable. So I work basically in English. It's stilted, it's formalized, it's limited English, but it's basically a long English sentence. Then a program called a compiler reads my English and turns it into executable code, which with the computer itself can then use. Within the where were we? Within the source code, some of the sentences are directed toward the machine, and some are directed to any interesting person who's looking at the source code. Those are called commentary or documentation or whatever. It's stuff the computer's not going to read. It's not going to read it. It's there to tell somebody else who's reading the source code where they are, what's going on here. And together the documentation should read off like a novel. If it's less than 1 line, you just begins with a double slash. Um, so hit a double slash and the compiler says, okay, that means ignore everything. If you're copy this, we'll copy it, but while we're compiling, we ignore everything to the end of the line, and when he hits enter, we start listening again. If it's real long, you start with a slash star and end with a star slash, and that means ignore anything in between. That's a message to the computer that this is documentation, commentary, explanation, people-oriented stuff. This is not the code. It has to read and then change over into the executable code, which the computer can read. So whatever's in the documentation, read it with gratitude. Somebody put that there for you. The program would have run just as well without the documentation. And don't think for an instant people don't make use of that. That is to say, you hire a guy, he works for your company, you say, do this with your computer. He writes a program. So then he starts demanding more money. You say, no, we can't not pay you anymore. We got other people who are senior to you, have done unexceptional work. Their work has been fine, as has yours. Okay, I'm quitting then. So quits, and you next time you need to use the source code, do a little tweak on it, go in there, there's no documentation. It's all just dots and slashes and there's no obvious shape to it. Well, the one thing they did was they wrote the C++ language, which makes it a little more clear what you're doing. The computer doesn't care, it can remember everything. But somebody trying to figure out how the program works from the source code has troubles unless the person who created it initially put in guideposts, put in commentary, put in the documentation. So the guy then gets hired back as an outside consultant on the program and goes off and sells his program to other people, of course. Well, I'm doing my best to give you commentary, documentation, to explain what's going on in the program, even if I'm not sitting here talking. Also, I'm giving you the program for free, and you can do anything you like with it. So it's like a long run-on sentence. Every clause ends in a semicolon. You put spaces at, logical places. For the benefit of the person who's reading the source code, the computer has no problem ignoring spaces. And you don't put a capital at the beginning or a period at the end, and I think that's kind of a pity, because otherwise the program would be a reasonably proper run-on English sentence. So, first comment. You see the there. You see the /star. This is not part of the program. This is not talking to the computer. It's talking to you, the person reading the program. It's programmed to simulate the behavior of population, limited in size by decreasing fertility with greater size and less kin members on average. The program models the genetic makeup, and we now know, which I didn't then, it's really the epigenetic markers, the methyl groups that are being modeled in the population. I did say genetic, understood in the broadest possible sense, includes epigenetic and any other inheritable factor. Program was named on my computer accumulating for accumulating fertility, and then we load our tools. Okay, that's what you'll read in the documentation. Include IO stream. All right. there's a whole bunch of orders here. They're telling the machine to load these reflexes. You know, when you say, I want you to read something from the console, which is, you know, the screen and the keyboard or however you're getting information in and out. I want you to read something. You don't stop and go through all the documentation of how to read stuff every time you say bring in the next number. So you can load something they call IO stream, input output stream. Okay, you won't see the red in the documentation. You will see other things. Okay, here's when include. Okay, there's our hashtag sign, pound sign. Include braces, see math. Okay, that means bring in from the library a bunch of reflexes that let you do arithmetic and find random numbers and that sort of thing. Okay. See out, console out, standard use, standard console out, right? That's when you put something in, it comes up on a screen like everybody else using standard console in, CN. All right, you got the general drift there? Okay, once we've got the tools loaded, then we can start putting in variables, and variables can be put in any time. You know, let's see, it's a little hard to read here. Can you see that? Int space gens. Now notice that gens is capital G. It's only a name. Gens is not a part of C++ language. It is a name you're telling C++ that's going to be used. And that can have a capital. Nothing in C++ itself is capitalized. Anytime you see a capital, you know that's a variable, that's not an order. It's a variable. It's the name of something that you're going to be talking about. And if you read down here, you'll see that as best I can, the names are self-explanatory, and mostly they're integers. Integers, you know, numbers, whole numbers. A long integer is an integer that's 2 bytes long. Okay, it's a lot bigger number, and when you're using bigger numbers instead of little ones, you need to have long integers. So that's why those are long or not so long. And so after that, we start loading our arrays. Now, an individual here is going to be a series of numbers, right? So, let me get where I can reach. You got braces there? That announces this is an array. It's not just a variable number, it's a set of numbers. And every individual is going to be a set of numbers, and every chromosome in that individual is going to be a set of numbers. And but that's all included in the array for the individual. Then all the members of a population is an array in which you can think of it as rectangular. All your individuals are lands this way, and then they're the members of your community. And then you have the biggest array of all, which is the possible offspring you might have. So we have a list of individuals. You choose mates, assign mates, let them reproduce new individuals. Each one has an array, and stick them all into the next generation array, which is huge. And then you go through the next generation and eliminate enough to bring that number in that array, the number of individuals, bring that to maximum population size, max pop size. So those are the arrays. Let's see. We start the random numbers here, and later, so S rand parenthesis times 0. The computer looks at that and says, oh, times 0. That must be when we started. And we looked at the clock, and how many seconds has it been since the first of the year? All right, we'll count that many seconds down in our enormous table of random numbers and grab the first number and say, okay, there's your first random number, and then the next in sequence. They are not really random, they're pseudo-random. People from time to time figure out what some real random numbers are, but it doesn't really make that much difference unless the chances of being significant are remote. But even so, there's some things that will be so rare that you need a really big random number to say, okay, this is one chance out of a zillion. We got to have a zillion as a random number. And so what I do is I multiply two random numbers together and get a huge random number. And there's a flaw there, no question. That's not the way it's supposed to be done. But I couldn't think of a better way to do it. And I've never seemed to have had a problem. Okay, well, you can see what we're doing is that we are, okay, how many sites will be, will affect pre-zygotic infertility, all right? These are places where the console, the screen's asking the person running the program, the compiled program, give me a number. For instance, it says, okay, what's your initial population size going to be? What's your maximum population size? What's this part of an array supposed to be? What's that part of an array supposed to be? What's it mean? This is what it means. What numbers do you want? What's your mutation rates, methylation rate, things like that. Okay, so this goes on and on till you're heartily sick of it. Let's see, and then we start running a simulation. It will run multiple simulations. So sims equals 1, you got a capital, that's only a variable, and that means simulations. You say, well, I want 10 simulations. I tend to do that. And you can average them. So it's asked how many simulations. You say you're starting it, and then the computer says, okay, we're starting with simulation 1. You don't tell it to do that. It knows to do that. And then it's going to count up to maximum number of simulations. And while it's doing that, and then it's kind of like, it starts simulations, and then it'll start generations, and it'll choose individuals. So simulations begin and end, generations begin and end, individuals begin and end, transferring arrays begins and ends, making mutations, calculating the effect of the mutations. The whole thing tends to be nested. So when you see something that's a brace going one way, you know sooner or later you're going to get the corresponding brace going the other way, and that means you come back out. And so you can read this as well as I can, actually probably better. You read on down and see how the thing works. And then you can make any changes in the program you like, or you can simply have the program compiled. And if you've got a compiler, it'll have okay, do you want a new program? Fine, file new. Good, paste in your data. You paste everything and no more than what's in the program. Paste that in, okay, and there'll be a big exclamation point. Say, okay, now we're going to compile. And if you've done it at all in C++, that should all be familiar. If not, if your version is more recent than mine and it works differently, then you see, you take you some time here. Okay. So here is end sims. You see the brace going the other way, where it says end sims. We close. That's the other side of the brace. We saw way up there where it starts as, first simulation. Okay, and then it's going to give you some C outs, meaning this is what our results are. And then it'll save a file that'll include what you told it to run. All those things you added in the beginning is now going to tell you what you added in. And it'll be in a file, and then it'll put the results in a file, and it'll offer to store a whole population. So you can say, okay, save this population, and you can bring the population back in and run it again under different circumstances. You can have a favorite population that you bring in and run it and see what happens, and then you bring it in again and run slightly different variables. Like you don't want to start with all zeros every time if you're being real fussy. Okay, if you're still here, congratulations, you are made of stern stuff. I have to admire you getting through this. Now, since you're have such mental strength, fortitude, patience, determination, you highly motivated, you really care, I guess you're the one who's supposed to save the world, so get busy on it. There may be enough time, I don't know, but I'm absolutely sure there's none to spare. So, yep, there you go. Now you have the theory, which is the program, and that means that's a quantitative theory. If someone has a theory about something, I think geese fly to the far side of the moon in the winter or something. You say, well, okay, what are your numbers? What's the distance? That sort of thing. That calculation won't, that theory won't fly because the numbers don't work. So you got a theory that'll give you numbers, so you can check that out against reality, as we have done, will be doing that sort of thing. Okay, that'll wrap it up. See you next time. And I, for one, am glad this one is over. Alexa, turn off light 1.